Hi dear students, today let us study a new chapter, Polynomials. In our 8th class, we have already studied about algebraic expressions, how to deal with them, their addition, their subtraction, multiplication and division, right? We completed that one in our previous classes. So what we have studied in our 8th class, the same topic we are going to discuss here in a new method. Especially we are going to get a little bit deeper into that algebra. That's what we are going to study in this chapter. Okay, so what are polynomials? That's the first topic which we are going to deal with, and in this chapter we will be studying three things mainly. One is what we call the factor theorem, second one is what we call the remainder theorem, and the third one some algebraic identities. Algebraic identities, actually what is the meaning of identity? Here this algebraic identity means we have studied in our 8th class. Let me remind you something. We have studied about a plus b the whole square. What was a plus b the whole square? A square plus 2ab plus b square. What about a minus b the whole square? A square minus 2ab plus b square. And a square minus b square, that was a plus b into a minus. These are the three identities which we studied in our 8th class, and in this class, especially in our 9th standard, we will be discussing some more identities. Actually, why are we using this identity? Where should we use this identity? Whenever we see a particular problem, and in that problem, if it is of the form a plus b the whole square, there is no need to, what is the meaning of a plus b the whole square? A plus b into a plus b, because 2 square means 2 into 2, 4 square means 4 into 4. So a plus b the whole square means a plus b into a plus b. When you are multiplying two terms like this, you have to multiply each term, right? It will become a bigger term. So you have to go through plenty of big steps in order to reduce the total steps, and it is a single step itself to receive the answer or to find out the solution for the given particular problem. We will use these identities. Actually, these identities, they helps us a lot to get the solution in an easier method. That is the actual use of identity. And in this section, we are going to discuss about polynomials and some algebraic identities. The first section is polynomial in one variable, a single variable. Normally, what is the meaning of variable? An unknown thing. Whenever you don't know an unknown particular quantity, we will think that it is x. We will assume it as x or y or z. These are the three letters normally which we denote for any particular variable. For any so-called variable, if you are taking a variable, if you are assuming a variable, see, I will tell you what is the study of algebra. For example, if you don't know, I'm just giving you an example, okay? If you don't know how much amount is there in my pocket, you have no idea how much amount is there in my pocket. So what you will do, you will consider it as x. That is what we call the study of algebra. You don't know exactly how much amount is there in my pocket, so you will consider it as x. Then I will give you some hint regarding this particular amount which is kept inside my pocket, and then you will just analyze. You will start making some expressions using this x. And if I am saying, see, that guy who is next to me, he is having twice the amount of that which is in me. Okay, how much amount I am having? You assumed it as x. Now I told the guy very next to me, he is having twice the amount than which I have. So at the time, what will be his amount? It will be twice of x, 2 times of x. So these are what we call this x or this y or this z, which you assumed is what we call the variable. So these are the normal 3 letters which denotes for the variable. And in front of the variable normally lies a constant number. It can be 2x, it can be 3y, it can be minus 7y, minus 7z, minus 1 by 2x, like this. Whatever number is lying in front of that variable, that typical number is what we call constant. Let us take an example here. 2x, 3x, minus x, and minus 1 by 2x. Okay, 4 examples took here. What is the first time? It is 2x. You can see here, x, I already told you this x is the variable, right? x is a variable, and in front of x you can see there is 2. So what is this 2? This 2 is what we call the constant. Constant means it is not varying, it is static. The value of that number never changes. Variable, in that particular term itself, it is there, the meaning is there. What is called variable means varying, it can vary. So the variable and the constant part. Second example, 3y or 3x or 3z. Here it is 3x. So 3x means x is the variable part, 3 is the constant part. Next one, minus 1 by 2x. Minus 1 by 2x. Minus 1 by 2 is the constant part, x is the variable part. Before that one, minus x. So it is just minus x. There you can't see any number. Can you see any number there? No, there is nothing there. But in the other 3 examples you can see 2 was there, 3 is there, minus 1 by 2 is also there. But in this example it's just minus x. So what is the variable? It is x. That is clear, right? The variable is x. What about the constant part? If there is no number in front of that variable, we will regard it as 1. And here you can see there is a minus sign also. That's why we will say minus 1 is the constant here. And in some cases there will be no numbers. Like this, there will be no numbers given there. So if no numbers are given at the time, we can assume, we can choose A, B or C, means small letter A, small letter B or small letter C as constants, so that the variable or the polynomial, it will be represented as ax, by or bx or cy or cz, like that. A, B and C, normally these 3 particular letters or these alphabets are used to denote the constants. They will represent the constant. Okay, so a constant along with a variable is what we call a polynomial. A constant multiplied by a variable. Is that clear? Now, how many terms are there in a polynomial? We are going to that topic. What are the total terms? How can we identify the terms of a polynomial? Let me give you an example. Here let us take an example. X square plus 2x. Okay, x square plus 2x. Here you can see x square, right? That is a variable. 2x, another variable. In between x square and 2x, you can see there is a plus sign, right? There is a plus sign. So this plus sign separates the variables into 2. Before the plus sign lies x square, after the plus sign lies 2x. So we can say there are 2 terms. So how can we identify how many times are there? There should be an additional sign. That means there should be a sign of the addition or the sign of subtraction. Means either plus should be there or minus should be there. So here anyhow plus is there. That's why we can say in these terms, in this given polynomial, there are 2 terms. Is it clear? There are 2 terms. So number of terms we can understand. Like let's take one more example. Minus x cube plus 4x square plus 7x minus 2. Here you can see how many terms are there. Just count me and tell. Count it and tell. How many? Yeah. First term is minus x cube. Second term is plus 4x square, right? Third term plus 7x, and the fourth term minus 2. Means in front of plus, in front of minus, we can separate the term. First term you can see it is a cube of a variable, x cube minus x cube. Second one is a square. Third one is simple x, and fourth one is just a constant term. It's just a constant number. It's a number, that's it's a constant term. So how many terms are there here? There are 4 terms. So in front of x cube you can see there is a minus sign, right? There is a minus sign in front of x cube. I told you if there is no number we will regard it as 1. We will consider it as 1. So we can say there is minus 1 in front of that one. So this minus 1 is what we call the coefficient. Minus 1 is called the coefficient of x cube. Means, so what is the meaning of coefficient? The number which lies in front of that variable, whatever variable you are taking. Right now I told the coefficient of x cube. So focus your eyes on x cube. In front of that, what is the variable? What is the number there? Choose that number. That number is called the coefficient. Then what about x square here? What is the coefficient of x square? Just fix your eyes on x square, the term x square. So in front of x square you can see there is plus 4. So we can say this 4 is the coefficient of x square. Is that clear? So like this. Now My question is, in some case, some students they may be thinking, see, I will give you one question from that. Let us take three numbers, 2, -5 and 7. Three numbers. My question is this polynomial? Is 2 a polynomial? Is -5 a polynomial? Is 7 a polynomial? Already I told you, polynomial means, what is polynomial? A number multiplied by a variable. But here the variable part is not there. After 2 you can't see any x there. You can't see any y. You can't see any z. So the variable part is missing. Even though the variable part is missing, actually 2 can be written as 2 into 1, isn't it? 2 can be written as 2 into 1. And in our 8th class, we have studied any number raised to 0 or any letter raised to the power of 0 is regarded as 1. Any number raised to 0 is equal to 1. So here, instead of 1, we can write it as x raised to 0. So 2 means 2x raised to 0. So there is a x term there. There is a variable. There is a hidden variable. So we can say, even though if you are taking constant numbers, that numbers are also regarded as polynomials. Clear? And now there is one more question inside this one. What about 0? Here I took three numbers. Two of them were positive number, one is a negative number. What about 0? So for 0 we will say it is regarded as 0 polynomial. It is regarded as 0 polynomial. 0 is called the 0 polynomial. Because I am giving this information because in some brainstorming classes or here and there if you are going, sometimes they may be asking this typical type of tricky questions so that you can understand what it is. Okay, that's why I just gave you an information regarding that. 0 is also a polynomial, and that polynomial is what we call 0 polynomial. Is that clear? See, is there any condition for something to become a polynomial? Means right now I told you what is a polynomial? A number multiplied by a variable. That is what we call normally polynomial. Polynomial may have plenty of terms. Right now, first of all, I told you 2x, it's a polynomial with a single term. Then we studied about x square plus 2x. That's a polynomial in two terms, having two terms. Thereafter, we took another example which are having 4 terms. So like this, there are numerous, we can take numerous polynomials with plenty of terms in them. So my question is there any special thing regarding this? Means, is there any particular rule, okay, or particular specific condition for something or from something algebraic expression to become a polynomial? Exactly, yes. Now let us study about the conditions for an algebraic expression to become a polynomial. The condition is this one, that the powers, what is called the power? The thing or the exponent, it is called also the exponent. For example, you are taking x square, just think about x square. On the top edge, right hand side, you can see s2 is written there. X raised to the power of 2, that is normally called as x square. And this 2 is called the power of that polynomial, or it's called the exponent of that polynomial. And this exponent should always be a whole number. What is a whole number? What is a whole number? Whole number means it starts from 0. Right? All the natural numbers including 0 is what we call whole numbers. 0, 1, 2, 3, 4, 5, 6, all these things are whole numbers. Never take a fractional number, never take a negative number. That doesn't belong to the category of whole numbers. So the only thing which you have to notice is the power of every variable. Whatever variable is there in the given algebraic expression, all the powers of the variable should be a whole number. That is the main thing which we have to notice. Clear? Now let us take an example. X plus 1 by x. X plus 1 by x. It can be written as x plus 1 by x is equal to x plus x raised to minus 1. You have already studied in your 8th class that 1 by x can be represented as x raised to the power of minus 1. Now check out these two terms. The first term, it is x. What is the power of x? It is 1 because nothing is written there. That means it is having the power 1. What about the second term? X raised to minus 1. Minus 1. Is it a whole number? Is minus 1 a whole number? No. So minus 1 is not a whole number. That means this particular statement or this particular algebraic expression is not a polynomial. This never comes under the category of polynomial. Let me give you another example. Root x plus 3. square root of x plus 3 is equal to, this can be written as x raised to 1 by 2 plus 3 means root of x means x raised to 1 by 2. It's already in 8th class, right? Cube root of x can be written as x raised to 1 by 3 like that. So here you can see the power of the first variable. Is it a whole number? Is it a whole number? No. Then what is it? It's a fractional number. So I told you, if it is not a whole number, neglect it. It will never come under the category of polynomial. So we can say this is not a polynomial. This is not a polynomial. So in this way, we can understand whether the given statement is a polynomial or not. And now, general term of a polynomial can be represented as p of x. Means if you are taking any polynomial, say I will give you an example, 2x square plus 5x minus 3. This can be written as p of x is equal to, we will write p of x is equal to. What does it mean by p of x? After p you will put one bracket and inside the bracket you will put that x. And we will read it as p of x. P of x means polynomial in x, polynomial of x or polynomial in x. If it is p of y, that means all the variables will be of y. Here you can see all the variables are of x. So we can say it is p of x, or we can represent it as q of x or r of x. These are the general things, p of x, q of x, r of x. These are the normal things which we use to represent any given polynomial. So when you are saying p of x is equal to, that means that polynomial is equal to the given polynomial. If two polynomials are given in a question, we will take one as p of x, another one will be q of x. If it is in x, we will take p of x. And if the question is giving, inside the question, if it is given if it is given as y, if the variables are y, then we will write p of y. Okay, that much, I hope that much is clear for you, right? So simple. So these are the basic things which we have to understand. Now, already I discussed about the total number of terms, how to understand how many numbers of how many terms are there in a given polynomial. If there is only a single term in a given polynomial, that polynomial is called a monomial. Mono means single. If there are two terms, we will say it is a binomial. Bi means two. If there are three terms in a given polynomial, it is what we call trinomial. So monomial, binomial, trinomial. Monomial means it will be having only a single term. Binomial means there will be two terms. Trinomial means there will be three terms. Is that clear? And more than that, we will call all these things as polynomials. Poly means plenty. Earlier I told you about the power of each variable. Another term of the power is what we call the exponent, right? Exponent of each variables. So if you are considering this exponent, if you are taking one polynomial here, let us take an example and I will come to that point. Here it goes. 3x raised to 7 minus 4x raised to 6 plus x plus 9. So here you can see how many terms are there? There are 4 terms. So this is a polynomial of 4 terms. So inside these 4 terms, you can see x raised to 7, that is the first variable. What about the second variable? It is x raised to 6. What about the third one? It's only x. What about the fourth one? There is no x. Actually, even though you cannot see any x there, there is x raised to 0. Forget not. So here, in these 4 terms, tell me which of these are having the highest power? What is the highest power? 7, right? 7 is the highest power. So we can say as the highest power is 7, the degree of this polynomial is 7. The degree of this polynomial is 7. One more example. 5y raised to 6 minus 4y square minus 6. So y raised to 6, y square, then 6. This is a polynomial in y. So we will write p of y is equal to, it is not p of x because it's a polynomial in y. Now what is the highest power here? It is 6. So the degree of this polynomial is called 6. The degree of this polynomial will be 6. So how to understand what is the degree of a given polynomial? How to understand that one? Just to check what is the highest power. And regarding this highest power, they are classified into numerous things. If the degree of the polynomial is 1, that polynomial is called a linear polynomial. Linear means along a line. Linear polynomial. Second one, if the degree of the polynomial is 2, that means the highest power of the given polynomial is 2, then that particular polynomial is called a quadratic polynomial. So linear polynomial, quadratic polynomial. Third one, if the degree of the given polynomial is 3, if you found as the degree or the highest power of the given polynomial is 3, then that polynomial is considered as cubic polynomial. So linear, quadratic, cubic. And if the polynomial is having the degree as 4, means the highest power is 4, that typical polynomial is what we called a biquadratic polynomial. So these are the 4 categories. The first one, linear polynomial. Second one, quadratic polynomial. Third one, cubic polynomial. And the fourth one, biquadratic polynomial. Now there may be some kids, those who are thinking like this, what about 5, 6, 7 and 8? For 5 normally we will say it is the 5th degree polynomial. 6 we will say 6th degree polynomial, 7th degree, let us go like that, okay. This much is enough actually. The first 3 things are so important because in your 10th class also you will be dealing with this first 3 categories. So keep this 3 things in your mind. Whenever you are hearing the word linear, it should come into your mind. It is an equation with a, or it's an expression with a degree 1. When you hear the word quadratic, what should come into your mind? Quadratic. Okay, quadratic means the degree of the polynomial is 2. Cubic means the degree of the polynomial is 3. That should come automatically into your mind. Is that clear? Now the next thing which you have to understand about polynomial is zero of a polynomial, zeros of a polynomial or root of a polynomial. So what is called the zero of a polynomial or what is called the root of a polynomial? See, normally when we are studying social science or science or anything else, any other subjects, there are questions and answers, right? We will ask to our teachers, teacher, what about question and answer? When are you going to give this question and answer? We used to ask like that. So we are familiar with question and answer. I have seen plenty of students used to write ANS, a short form to answer. So in maths, we never used to write ANS, right? Because it's not an answer. Neither a question is given in front of you. If you're checking your textbooks and if you're going through the examples also, you can find problem solution. A problem is given in front of you. You have to solve it. There is a problem. It's not a question. They're not asking you something. What about that one? What is this one? What is that one? Never. You can see such typical types of questions in mathematics. It deals with problems and solutions. So whenever you are given a problem, you have to solve it. Solve means find the answer of that one. So in this particular chapter of polynomials, whenever you are going to find the solution of a polynomial, that solution is what we call the root of a polynomial, or it is called the zero of a polynomial. Is that clear? It is called zero of the polynomial, or it is called the root of the polynomial. Now I will tell you why it is called as the zero of a polynomial. We will never say find the answer of the polynomial. Actually that is the meaning. Is it clear? Actually that is the meaning. If a question is given in front of you, or if a problem is given in front of you, you are there to solve that problem and you will get an answer for that one. That's what we call the solution, right? You will get a solution for that one, and this solution what you receive is what we call the root of the polynomial, if it is inside polynomial. So you have to study the language. You have to study the language of maths. In polynomials, we will never say answer, we will never say solution, but we will say, instead of that one, we will say the root of a polynomial, or we will say zeros of a polynomial. Now why is it called zero of a polynomial? I will tell that one. Let us take an example for that one. Here p of x is equal to 5x cube minus 2x square plus 3x minus 2. It's a polynomial in x. Let me ask you a small thing. What about the degree of this polynomial? What is the degree of this polynomial? It is 3. It is not there in the question, I simply asked. It is a third degree polynomial. If it is a third degree polynomial, what is it called? A third degree polynomial is what we called cubic polynomial. So here we got a cubic polynomial. Now this is p of x. Now let us find p of 1. So p of x is given and I am asking you to find p of 1. Means instead of this x, we will put within the brackets 1. That means you are substituting the value of x with 1. You are changing the value of x. You are substituting the value. You are taking away the x and dropping 1 there. So wherever you see x in this particular equation, wipe out all the x from there and just replace it with 1. substitute it with 1. So it will become P of 1. Let us find the value of that. P of 1 is equal to, so here you can see 5x cube. So we will write 5 into, instead of x we have to write 1. So within brackets we will put that 1 cube. Why we are keeping this bracket? You should keep that bracket whenever you are changing a value, whenever you are inserting a value, substituting a value, it should be within brackets. It should be within bracket, because there are some cases that negative numbers also we will have to find, means P of minus 1, P of minus 2, like that also some problems are there where you have to find the value of negative numbers. So at that time, most probably if you are forgetting to keep that bracket, just imagine that in this question you forgot to keep that bracket. What will happen? You will write 5 minus 1 the whole cube. In the next line you will think, okay, what is 5 minus 1? You will write 4 cube. So something else you will get. Just because you forget the bracket, that will become something else. Even a single dot is important in mathematics. So don't simply point here and there. Okay. So that's why I tell you, be very alert when you are dealing with mathematics. Clear? So here I remind you, forget not to keep the substituted value within bracket. So here we are keeping the bracket 5 into 1 the whole cube. The bracket is read as into 5 into 1 the whole cube. Next term, minus 2 into, that numbers are dropped like that itself, minus 2 into, within brackets again 1 square, then plus 3 into 1 minus 2. Now that is equal to, what is 5 into 1 cube? 1 cube is 1, so 5 into 1 it is 5 itself. So 5 minus 2 plus 3 minus 2. Finding the value of this one, adding them together, what you will get? 4 is the answer. So now here you got 4, means P of 1 is 4. Okay, P of 1 is 4. I'm going to come to the point root of the equation, or I am coming to the point 0 of the equation. So focus on this particular term. Okay, P of 1, when you find P of 1, you got the value 4. You got its solution as 4. Just take a pen and paper, just find P of 2. Instead of this 1, substitute it with 2, you will get another answer. If you are substituting it as minus 1, you will get, if you are putting there minus 1, instead of this 1, if you are putting there minus 1, try it for yourself. I will give you the answer. It will be minus 12. Find it, you will get it. So while giving different numbers like this, by trial and error method, simply drop some numbers there. P of 1, we found it here. Find P of minus 1 and find P of 0, then P of 2, P of minus 2, P of 3, P of minus 3. And when you are taking some numbers, and if you got the value 0, by final calculation here you got it as 4. Like that, if you got it as 0, then that typical number which you substituted there instead of x, that digit or that number is called the 0 of that given polynomial. Because what is the meaning of that one? When you kept that number, when you substituted the number for x, the total value of the polynomial became 0. Here, when you substituted the value of 1 for x, when you substitute the value of 1 for x, what happened? The value became, or the result came as 4. So in such a way, if the result came 0, then that number which you substituted is what we called the 0 of the polynomial. I hope now you got the term, the meaning, 0 of a polynomial. 0 of a polynomial means if you are keeping that value, if you are giving that value inside that particular given polynomial, the total value of the polynomial will become 0, and that is why it is termed as 0 of the polynomial, or it is called the root of a polynomial. Hope you understood. So this is the introduction part regarding polynomials. So what is polynomials? Then how many terms are there? How to identify the terms? Regarding the number of terms, how are they classified? Then what is called the power of a polynomial, or in other words, what is called the exponent of a polynomial? By seeing the exponent, how can you understand the degree? By seeing the degree, how can you identify whether it is linear polynomial, quadratic polynomial, cubic polynomial, or biquadratic polynomial? Then what is the term coefficient called? Okay, these are the things which we discussed right now. So this is all about the introduction part. If you understood this much things, then the study of polynomial will be much more easier, because this is the base, this is the foundation which you need so as to get into the study of polynomials, because this is so important. In 10th class, the 2nd to the 4th chapter, 2nd to the 5th chapter, we are dealing with all these particular polynomials. So this is the base of polynomials. So study hard. Hope you understood the topic. So this is all about today's class, and I hope you enjoyed the video. So keep watching the video.